right, we're in chapter 8, which is called Measures of Center. It sounds really fancy, but it's not. A measure is, for our purposes, a single number to represent information. To represent information. And the information in our case is going to be our sample values that we get from repeating an experiment of some kind. That could be dice rolls, it could be phone conversations, it could be many things. In this chapter, we're going to look at house prices. I have a bunch of different sample values. And yes, they have all the detail, but it's nice in some cases to have a single number to represent the collection of sample values that we have. However, we have the slight problem of it's convenient to only look at one number. So we have convenience, but we lose detail. We lose the detail of each sample value. So it's a trade-off between seeing all sample values, but having all kinds of numbers. All the details there, but it's not as convenient to look at. If I want the convenience by way of a single number to represent all of this, I'm going to lose some detail. So how do we do that to have this trade-off be still okay? Well, the first one, we're going to have 3 of them. The first one is the average, and it's also called the mean. So let's look at it by way of an example. Let's suppose we have some house prices in a certain neighborhood. And let's suppose we have, I'll just stick to the book so you don't look at this in the book and get confused between the two. Let's suppose we have a $250,000 house, and then we have a $300,000 house. Clearly not in Victoria, but still somewhere this could happen. 350. We have a smaller $150,000 house, $250,000, and one more, $200,000. We have those 6. So we have a small little sample of those 6 house prices. If you ask everyone randomly, how do I calculate an average? I'm simply going to add them up. Add sample values, and then divide by how many there are. I think almost everyone can calculate an average, also called the mean. So I have 250,000 plus 300,000 plus all of them, as many as you have in your list. And I divide by how many there are. There are 6. Hopefully everyone is familiar with that calculation. Not a new calculation. I'm sure somewhere in later elementary school you can easily teach this. What do we get as the average? 250,000. So that single number acts as the best representative number for what's happening in the neighborhood. You get house prices that are higher, house prices that are lower, but they sort of center on that 250. So if I just tell someone the average house price in that neighborhood is 250,000, it gives them a fairly good idea of what's happening in the neighborhood. So it is convenient, but I don't know the exact house prices, so I have lost some detail. So now if I expand on this, let's sort of continue this exercise, or example, sorry, it's not an exercise in the book. And let's suppose someone moves in, some celebrity or someone with more money than that neighborhood is used to, and they build a fancy house valued at 1.3 million. Because they have the money, why not? Then my new mean, my new average house price is now going to take the previous, add them up, everything the same, all the way in that original list, but now also this new one is one of the neighborhood houses that I'm considering, and now I have 7 of them. So I'm still calculating the mean, the average in the same way as always. I've just added a sample value. So now I have 7 instead of 6. What is the answer to this calculation? 400,000. So the addition of this extreme house price relative to that neighborhood changes my mean a lot. We say that the mean is sensitive to these extreme values. Extreme values are called outliers. They're lying outside the cluster of values I'll usually get. That if I have one of these outliers in my sample, it's really changing the effectiveness of that mean and how it represents what the neighborhood is actually about. So it has the drawback, yes, it's convenient, but it's really very much dependent on the actual numbers. If I have a sample of values that are all sort of the same, then the average, the mean is really good. But these extreme values can really skew things. It pulls this calculation towards it, and then the mean isn't necessarily an ideal representation of what's truly happening for the majority of the neighborhood. Any thoughts or questions on that? Easy enough so far? Okay, good. I don't want the last chapter to be super difficult. Make a new page. So, in an attempt to bypass this sensitivity that the mean has, there is the alternative option of the median. So for the median, what I'm going to do is, whatever sample values I have, I'm going to arrange the sample values from smallest to largest or the other way around. Doesn't really matter. And then I'm going to choose the middle one in that list. Middle value in the list. Now let's take this previous example, and I'm just going to write them again here. Our continued example of 250,000, and then we had, copying them just from the book, 350, 150, and 250, 200,000. And then, of course, the 1.3 million one. Like that. So then first I have to arrange them. I'll just do increasing order. So I'm going 150 is first, then I have a 200, then I have a couple of 250s, just a couple. Then I have a 300, then I have a 350, then I have 1,300. 7 of them. So then if I count in from either side, the middle one is that one, and that is the median. It doesn't take into account what the sample values are. The average uses all the actual values and mixes them up in that calculation. The median doesn't care. This could have been a $2 million house. The median is still the middle one. It doesn't matter. So it's not sensitive to those extreme sample values at all. Just how many there are. And if there were that many $1 million houses, well, then the neighborhood is different, and the median should perhaps represent that. But one outlier doesn't affect the median at all. So it is an improvement in some sense, in that sensitivity issue. It's an improvement upon the mean, that this one isn't as effective. I just want to note that if I look at the very first example, and just sort of on the side here, I calculate the median. If I now arrange these 6 numbers, I have 150, I have 200, 250s, I have 300, and a 350. In the case of having an even number of sample values, the middle is not a specific number. I then take the middle 2, and the median is going to be the average of the middle 2 values. In the case of having 7 numbers, an odd number, there is a middle sample value, and that is exactly the median. In the case of an even number of sample values, there are 2 middle ones. And I'll just average them out. In this case, it's still 250. But in the case where they are different, I average out just those 2. So I handle the median, finding the median a little bit differently depending on how many sample values I have. But in our future catch-up days, we can see all the variety in the problems. Any questions on the median? Is the median a word that you knew already?
Yes.
Maybe, maybe not. And then the last one, less important than the first 2, but still, to complete the picture, we have the mode. And the mode is simply the sample value that occurs most often. If I look at this example we see in the continued example of house prices, I see that 250 occurs more than any other number. 250,000 is the mode. And in some cases, it adds to clarify the picture of what's happening in this neighborhood. On its own, it has limited benefits, but in addition to the mean and median, they can help clarify what's happening. The drawback of the mode is sometimes I can have more than one sample value that occur equally often, and then they're all the mode. Or sometimes all the sample values are different, and then there is no mode. So it's not as applicable when I compare it to the mean and the median in every single case, but it has its place now and then. It's the same as we had. Psychologists surveyed 15 single senior citizens, phone conversations, same thing. Our numbers might be the same as well. I think they are. We did the frequencies and everything, and that's good. A graph also sort of more easily represents the information, but we will calculate the mean. That's where I just add them all up. You don't have to write them all. I'm just emphasizing that we're adding all the way to the end. And they're nice enough to also tell me we have 15. That might not always be the case. And I get an average number of phone conversations. That 7 is high. I'm not seeing it as an outlier because the 5 and the 7 are sort of the same order of magnitude, same size numbers. What do I get for the mean? Say again? 2.3. 2.2. Which one is it? 2.2. Okay. And then the median has a different requirement. I'm going to have to arrange them all. Let's do it. I have a 0 as the small one and another 0. I have 3 zeros. And my challenge here is to just make sure I don't miss anything. How many ones do I have? 5. 1, 2, 3, 4, 5. 2s, I have only 1. 3s, I have 2 of them. 4s, 2. 1 5. And a 7. So I can check this by counting if I have 15. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, good. So then the middle one, I count 7 in from either side. 1, 2, 3, 4, 5, 6, 7. 7. So the median is 1. The median and the mean won't necessarily be the same, but ideally they're in the same size number. I have a very small sample here, and the numbers only range 0 to 7, so it's hard to have them exactly the same. Larger sample, they'll be more likely to be close to each other. Depends where the sample really comes from and what the behind the scenes probabilities actually are. Any questions on finding the median? All right. Last one. Mode. What is the mode? 1. Done. There is, however, a little bit more that I find very relevant to our current situation. For that, I'm just going to look at an example. It's at the bottom of page 54. Suppose you work 2 jobs. In the first job, you work for 2 hours at $15 per hour. In the second one, you worked for 4 hours at, sadly, $10 per hour. What is your average hourly wage? Is it the average between 10 and 15? So 12 and a half? No, because you got $10 more often than you got 15. The average is 15 plus 15, two of them. But the 10s, there are 4 of them. I worked for a total of 6 hours. And the average that I get from that, when I plug it in, it is $11.67. That's the actual average that I made per hour. Because there are more 10s than there are 15s, it affects the answer much more. Because they're all the same, I could say it's 2 times 15. It's 4 times 10. And that 2 and that 4 is really what gets me the 6 in the denominator. So looking at that, we call these, the 2 and the 4, we call these the weights of the sample values in terms of excuse me, in terms of how often they occur in my sample of wage amounts that I got. And this is called the weighted average. I got 15 2 times. I got $10 4 times. Because the 4 is bigger than the 2, the $10 carries more weight in my average calculation, hence the word. Everyone happy with that? Weighted average. When the sample values sort of repeat themselves. It's only a question of how many there are, and we call those the weights of the sample values. How do we feel so far? All right. Now here's the extremely relevant part. If I look at exercise 8.2, and I realize I skip exercise 8.1, but we can come back to it. If I look at exercise 8.2, in the Math 143 grade calculation, quizzes contribute 40% in total to the final grade, while assignments contribute 10% and the final exam 50%. Number 1. Johnny scored 80% on his quizzes, 30 out of 40 on his assignments, and 82% on the final. What is his overall percentage? That's something that we definitely need to be able to do. And I find that students in general are not able to calculate their own grade, which is quite disturbing. So we have, on the one hand, different parts to your grade. We have the quizzes, we have the assignments, and we have the final exam. The contribution that they make to your final grade, your overall grade, is 40% for the quizzes, 10% for the assignment, and 50% for the final. These can be seen as the weight of each of those components. And then what we actually got, or Johnny, he got 80% on the quiz overall. Let's make that a percentage. 30 out of 40 on the final exam, on the assignment, not final exam. 82% on the final exam. So if I want to make these all the same, maybe I should convert the assignment to a percentage. 30 divided by 40 multiplied by 100 should get 75%. So then the overall percentage for his grade is a weighted average. His 80% quiz score, if you will, has a weight of 40. His 75% assignment score has a weight of 10. And his final exam has a weight of 50. And I divide by the sum of all the weights, which of course should be 100, and I have my overall percentage. We can't just log into the website and trust what it says. Unfortunately, spreadsheet errors happen, and you need to enable yourself with the skill to be able to calculate your grade yourself and verify that it is correct. What do I get in this case?
80.5%.
80.5%. So Johnny did pretty well. So this is probably the most relevant and important question for us right now. Being able to calculate your own grade. Yeah, I know there's an app for that, but having some skill to not be too reliant on technology makes me feel a little bit better. Any questions on that calculation? Yes?
Is the word at the top, the at, besides centrally, what does that mean?
Actually,
Actually, okay.
or whatever you want to call it, right? The weights and what he actually got.
Okay.
I didn't know what to write, so I just wrote something. Any other questions? Does it make sense? Can you calculate your own grade? In general, I've seen, not in this class necessarily, just in general, people are not able to do this. So let's do number 2. I'm going to skip number 3, but for number 2, why not? Good practice. So I have quizzes, same breakdown, so same weight. I have assignments, I have the final exam, and the weights are the same. Weights, still 40, 10, and 50. And then what they actually got in those different parts. Jenny scored 16 out of 20 for one quiz, 4 out of 20 for another, 19, oh, she got that, out of 20, 14 out of 20 for the fourth one. Assignments, she got 80%. Final exam, she got 40 out of 65. Now for me, the easiest is to just make this all percentages. One way or another, they all have to look the same. I can't use 80 and then use a 40 out of 65. I need to make them all look the same. And percentages are nice and intuitive for most of us. So the final exam percentage is going to be what? When it's 40 out of 65. What is that?
61.5%.
61.5%. And the quizzes, are you able to calculate your overall quiz percentage?
66%.
How did you do that?
You add up the scores and divide by 3.
You add up the scores, divide them by?
Divided it by 80. The total out of 80.
Oh, you can do that. Yeah. Or you can calculate each percentage and then average those. Many ways. Let me know if you're not sure. Was it 66.2?
66.2, yeah.
Oh.
0.25.
2.5. Ooh. That's a big difference. Oops, I'll zoom in. Look at 2.5. Then, our overall percentage. Again, is the weight of the quizzes times its score, the weight of the assignment times its score, the weight of the final times its score, over the sum of the weights, and hopefully she does okay. 61 on the final. See, because the final's weight is more than the others, it does have the largest say in that overall percentage. Something we know intuitively, but seeing it and seeing how it affects everything else and how little that 80 matters. Not nothing, but not as much as the final exam. What do we get for her overall percentage? 65.25. Not bad. Not bad. Not great, but it's not bad. Solid. All right. So the information could be presented as actual test scores or as percentages, and I just need to make them look the same. Any thoughts on that one? All right. I'll skip number 3 because it is the same. And I'm going to make a new page for number 4. Make a new page for number 4. Again, same breakdown. We have quizzes. We have assignments. We have the final exam. I like a table to just lay things out nicely. The weights are the same. 40 for the quiz, 10 for the assignment, 50 for the final exam. And now what we actually get is 75% for the assignment. Right? Quizzes, 18 out of 20. 18 out of 20 again. 16 out of 20, still good. And then a 12 out of 20. Okay. So we want to convert that to a percentage. Let's do that first. We have to do it anyway, might as well do it now. Why does it feel like Friday?
Weather.
Oh. And because we're done with the new chapters. Maybe that's why as well. Does anyone have a quiz average percentage? 80? Oh.
So sorry, how do we do this again?
Many ways. The simplest way could be to find each quiz percentage and then average those, add them up, divide by 4. That might be the simplest. Especially if the totals aren't the same, maybe the simplest way. It helps. There are shortcuts because they're all out of 20, but that's not always going to be the case. So now they say, what should she score out of 65? We don't know. In order to end up with an overall percentage of 60 or better. We want 60% overall. So now, because I'm working in percentages, let's call this final exam percentage question mark. Can we find question mark given the overall target? Well, yes, there are shortcuts to this, and if you understand what you're doing, you're welcome to take those. But if I calculate the average overall, it's a weighted average, 40 for the quizzes, and she scored 80. 10 weight for the assignments, and she scored 75. A 50 weight for the final, and she scored question mark that I have to figure out. Over, of course, is 100. 40 plus 10 plus 50. And I want that to be an answer of 60. Can we figure out what 60, not 60, I know it's 60. Can we figure out what the question mark is? Should we be able to? Kind of, yeah. I just have to isolate this question mark. Now, you can always take a guess and check approach and plug in some numbers until it works, or we can use some basic algebra. Multiply by 100 on both sides. I'll show the steps. Of course, you can merge some of these if you are more comfortable. Multiply by 100 to get 6,000 on the right. Simplifying the left-hand side. Then, let me not do any of that. I'll just emphasize here. Then these simplify to 6,000. This one simplifies to 750. This one simplifies to 3,200. Then I can isolate the question mark term by subtracting the others on both sides. Getting rid of them on the left, but they need to be subtracted on the right, leaving me with 2,800 to 2,050. And then how do I get rid of that 50? Well, it was multiplied, so I divide both sides by 50 to be left with question mark, which is going to be 2,050 divided by 50, which is 41. Now this looks like a bad number, but it's a good thing.
41 out of 65.
So this is 41%. So it's even better news. Meaning, out of 65, what does she need to get? So 41 divided by 100, because that's the percentage, times 65. 26.65, so at least 37. So it's all good news, because she did so well earlier, even with that 12 out of 20. One quiz does not ruin your grade in any way. She has very little pressure going into the final exam. Very nice. A situation I hope for each of you.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.